So for number 16, we're going to select the correct graph for a piecewise defined function. So I'm going to take one piece at a time. So my first piece will be that f of x equals x when x is less than 0. So that's y equals x, but only when x is less than 0. So my y equals x line, if I didn't have any restriction, then I would draw my y equals x line like this, where the slope is 1 and the intercept is 0. You know, there's all the points where x equals y, so 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, so on. But I'm restricted by saying x is less than 0, which means all this stuff on the right, x can't be positive. So I can take a piece of paper and cover up the right side of the graph where x is greater than 0, so that the only thing that's showing is x is less than 0, strictly less, not even equal, but less than 0. So then I have that green line. And the right side, that is not defined yet. In this piece of the function, it's only defined up to 0 and not including 0. Okay, so I'm going to move my paper here and change this line to just be up to that. Whoops, I need a pen now. To that 0, and there's an open circle there because it's not equal. All right, and then I have, for my second piece, now we have y equals x squared. And that happens when x is greater than or equal to 0. So now I have y looking when x is greater than 0, so I'm going to cover up the left hand of the graph and just draw the y equal to x squared. So that can be when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. So there's that parabola, or half a parabola, I guess, because we're only doing the x's positives. So there's that part of the graph. All right, so now I have my full graph. It has two pieces. The green piece is defined by the left hand of the graph, where x is less than 0. The purple piece defines the right-hand side. And then together I have one function that's defined piecewise. And that looks like our answer would be figure 3. In fact, I can tell it's figure 3 just by doing the first piece, because looking for this green line, that green line isn't anywhere else except for in figure 3. So that figure is going to be, just do it dark 3. Okay. I mean, you'll click your choose one and choose the 3, but okay. Now for the domain. So now we're looking at this function. What's the domain? So domain is all the possible x values. So it can go left. This green line keeps going left and left and left and left and left. And this right line keeps going right and right. I mean, it's going up, but it's going up to the right. So even though it's going to the right slowly, it's going to go to the right forever. So that will be to infinity, negative infinity. I use open brackets on infinity because you can never really reach infinity. And then the range is the y values. And just like this is going left forever, it's also going down forever. And this one's going up forever. So this will also be negative infinity to infinity. When is it increasing? This means as x goes, y is increasing as x goes from left to right. So you're going uphill. You're going left to right, you're walking uphill. So it's increasing. As it gets even steeper. It's never decreasing. So it's increasing for everything. And it's never decreasing. I don't think I need parentheses for that one. And it's also never constant. Constant would look like, a decreasing looks like it's a downhill line, and constant looks like a flat line. So both of those are nowhere for this problem. And that's number 16.